Question 14 asks me to rationalize the denominator. Remember, if you have a sum or a difference, you can't just multiply by the square root value. You have to multiply by the conjugate. You find the conjugate by flipping the sign on the radical. So that'll be 4 plus the square root of 5. That's a fraction, so I have to multiply the top by 4 plus the square root of 5 as well. So on the bottom, this is going to be FOIL. 4 times 4 is 16. 4 times the square root of 5 is 4 radical 5. 4 times negative square root of 5 is negative 4 radical 5. And negative radical 5 times positive radical 5 is negative 5. Notice the radicals cancel. That's the whole idea. 16 minus 5 is 11, so our denominator ends up being 11. On top, you've got radical 2 times 4, so that's going to be 4 radical 2. And then you've got radical 2 times radical 5, which is radical 10. You can multiply radicals by each other. So this one's actually going to be pretty ugly. Our fraction is going to end up being 4 radical 2 plus radical 10 all over 11. Not too catchy. All right. We have a line with a slope of 2/7, and it's crossing the x-axis somewhere. It doesn't say where. Remember, a slope is a rise over a run. So we're basically saying that somewhere on this line we could have a rise of 2 and a run of 7. It could look something like that. And we want to find the angle measure here. So I'm going to call that x, make a little right triangle. We've got the opposite side and the adjacent, which is a tangent relationship. So I could say tangent of x is 2 over 7. And I want to get the angle measure, so I need to switch my x and my 2/7, which means I need to use the inverse tangent or arctangent of 2/7. And so let's do that. And that angle measure is going to be approximately 15.95 degrees. Oh, it says 1/10 of a degree. So about 15.9 degrees. All right. Use a triangle to calculate trig values without actually using a calculator. For these, you can use any 30, 60, 90 triangle you want. I use one with a short leg of 1, a long leg of 2, and, a hypotenuse of 2 and a long leg of radical 3. So sine is opposite over hypotenuse. The side opposite 30 is 1, and the hypotenuse is 2. And if you check in your calculator, sine of 30 degrees really is 1/2 or 0.5. Cosine is adjacent over hypotenuse. So I go to my 30-degree angle. The adjacent side is radical 3. The hypotenuse is 2. It's going to be radical 3 over 2, which again should match the decimal on my calculator. Tangent of 60 is opposite over adjacent. Go to 60. Opposite side is radical 3. The adjacent leg is 1. You can really just simplify that down to the square root of 3. Tangent of 45, going to make a right triangle. The opposite side is 1, adjacent side is 1, and I usually use radical 2. Tangent is opposite over adjacent, and that is going to be 1 over 1, which of course is equal to 1. All right, 17 asks me to find the area of a regular hexagon with 20 centimeter sides. Leave it in radical form. So we have this hexagon. You can find the interior angle sum by taking the number of sides minus 2 times 180 degrees. In this case, that's going to be 6 minus 2 times 180, which is going to be 720 degrees. There are 6 angles, so each angle is 120 degrees. And what that tells me is I bisect those 120-degree angles when I create a triangle. We have little 60-degree angles down here. These are equilateral triangles, and side lengths are 20. So you can find the area of one of those triangles and then multiply by 6. I prefer to use the 1/2 the apothem times the perimeter formula. The apothem is going to be the height of one of those equilateral triangles with side lengths of 10. Side lengths of 20. So the half triangle has a base of 10, and that means the apothem is going to be 10 radical 3. So that's my apothem length. And the perimeter is just going to be 6 times 20, 6 sides, 20 units each, which is 120. And that's going to work out, I believe, to be 600 radical 3 square units. All right, 18, calculate the area of a regular decagon with 6-inch sides. I'm not going to draw all the sides here. I'm just going to draw kind of a piece of the shape, maybe something kind of like this. We've got 6 unit sides. The apothem is going from the center down to the midpoint of a side, creating a triangle. I'm going to use the 1/2 the apothem times the perimeter formula. A decagon has 10 sides, each of which has a length of 6, so the perimeter is 60. And we just need to find the apothem, which is going to require me to find the angle measures for a decagon. Okay, you could take the number of sides minus 2 times 180, and that's going to tell you that the angle sum is 1440, and you can divide that by 10. Each interior angle is going to be 144 degrees. If the interior angles are 144 degrees, half of that 144 is 72. That's going to be my angle there. I've got a side length of 3 here. I'm trying to find the apothem, which I'll label with an A there. So take your 72. My opposite side is A. My adjacent side is 3. That's a tangent of 72 equals A over 3. And I can multiply both sides by 3 here. 3 times the tangent of 72. It's going to be about 9.233, which you really need to leave in your calculator. So I'm going to take half of that, and I'll multiply that by the perimeter of 60, and we get approximately 276.99 square units if I round to the nearest hundredth. All right, next question. Determine the area of a circle inscribed in an equilateral triangle with 24 centimeter sides. So I can draw my triangle here. Here's my 24 centimeter side. Of course, the area of a circle is pi times the radius squared, so I need to find the radius. We've talked about the idea you can create little 30, 60, 90 triangles. You can draw the radius perpendicular to a side, which is going to bisect that side. Now be careful, this is the 60-degree angle here, which means this is the short side of the triangle. So this side gets multiplied by radical 3 to be 12, which means I've got to divide by radical 3 to get this length right here to get the radius. 12 divided by radical 3 is the same thing as 4 radical 3 if you rationalize the denominator. And so that's going to be my radius. So it's pi times my radius of 4 radical 3 squared. 4 radical 3 squared. 4 squared is 16. 3 squared, radical 3 squared is 3. 16 times 3 is 48. So it's going to be 48 pi square units for that triangle. All right. Last one on this page. Each side of the base of a square pyramid is 14 inches. The altitude is 24. Thought I had a diagram for this one, but maybe not. All right, so I can make my pyramid. Each side of the base is 14, and the altitude is 24, so I'm going to put a 24 in there. And you can make a little right triangle inside here like this. If this whole length is 14, that length there is going to be 7, and that means that this length here is going to be 25. There's a little 7, 24, 25 triangle there. The reason I did that, probably should have described why I was doing this. The individual faces are triangles with bases of 14, but if you're going to find the area of one of those triangular faces, you need the altitude of that face, and that's this length right here, which is called the slant height, which is that value of 25. So we have these 14 by 25 faces. Area of a triangle is half the base times the height, and that's 175. And we have 4 of those faces. So I can multiply 175 by 4. That's going to give me 700 square units. The total area, I can add the base. The base is going to have an area of 196 because that's 14 times 14. And so that's going to be 896 square units. The volume is 1/3 the area of the base times the height. The area of the base, we said 14 times 14 is 196. We already said the height was 24. And that's going to be 1,568 cubic units for the volume.